Lesson 31, looking at geometric sequences and series. Now, this one's very similar to Lesson 30 in terms of arithmetic sequence and series, except for now we're working with geometric. Now, arithmetic standard for adding or subtracting the exact same number every time. Let's take a look at the definition for geometric. It's a geometric sequence if the next term divided by the previous term is equal to some r value for all positive integers r. This is called a common ratio. Okay, again, so every single term has, if I take the next term and I divide it by the previous term, I will get the value that is constant all the way through. What does that mean? Well, if I were to multiply both sides by a sub I, over to here, I get the next term is really equal to r times that term, that previous term. So, really, for geometric, all I'm doing is I'm multiplying by the same thing every time. Okay, this is similar to multiplying by a fraction as well. So, 2a, a geometric sequence example could be something like this. I'm going to start with a 1. I'm going to get 2/3, then 4/9, then 8/27, dot dot dot. And again, you'll notice from here to here I multiplied by 2/3. From here to here I did the same. Okay, by multiplying the top by 2 gives me 4, multiplying the bottom by 3 gets me 9. Okay, so that right there would be a geometric sequence such that my r value is 2/3. Now, something that's not a geometric sequence, okay, is something, say, like this. Let's do 2, 4, 6, and then I'm going to do 12, and then 14, and then 28, and then 30. Now, you'll notice from here to here, it could be anything. Okay, I mean, it looks like maybe it's going to be adding 2 or multiplying by 2. Well, so let's look at this example here. From here to here, that also looks like we're adding 2. From here to here, it looks like we're multiplying by 2. So that one's very clear. That one's very clear that we're multiplying by 2. And then we add 2. And then we multiply by 2. And then we add 2. If the first few terms are confusing, it might be good to go ahead and look at the next terms to see. So, from here to here, this would then be multiplying by 2 and then adding 2. Okay, so notice again, I'm not doing the exact same thing every time. This is not geometric because I am not multiplying by the exact same term every time. Heck, I'm not even multiplying every single time. Okay, so that's not a geometric sequence. This one is where I'm multiplying the exact same thing every time. 3a, determine whether the given sequence is geometric. So I have 4, -2, 1, dot 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 all the way to 4 times a -1/2 to the power of n minus 1. Okay, now how do I determine if this thing is geometric or not? Well, am I always multiplying by the exact same number? Well, from here to here, it looks like I'm multiplying by a -1/2. Am I multiplying by a -1/2 here? Well, yeah, negative times negative is positive. And if I multiply by a 1/2, that cancels out and I get this. You'll notice this last term right here is actually the nth term. That is a sub n. Okay, it is a sub n, which you'll see in the formula number 4. Okay, so that is geometric. Now, how about this one here? Is 1, 4, 9, dot 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 all the way to n squared? Is that geometric? Well, this is 1, this is 2 squared, this is 3 squared, and so on and so forth all the way up till I get to n squared. But am I multiplying by the exact same thing every time? No. Okay? And actually, this doesn't even work for a geometric series. It doesn't work for a an arithmetic sequence. This is a sequence that is null and void of those two particular definitions. It is still a sequence. It's just not geometric, and it's not arithmetic. But it is a sequence, okay? And actually, it's a very nice sequence that we'll probably see come back around a couple more times. So let's talk about Formula 4. Formula 4 is a sub n is equal to a sub 1 r to the n minus 1. Now, why is it r to the n minus 1? Why isn't it r to the power of n? Well, in terms of this particular setup, am I multiplying the first term by r right in the beginning? For instance, if I go back to this right here, did I take 4 and multiply it by a -1/2? Well, yeah, but I did that to get to the second term. So this is the first term. I am not multiplying it by the r value. So I have the a sub n term is equal to a sub 1, such that if I plug in 1 here, I'm supposed to get 1, because I'm not supposed to change the first term to get a sub 1. Okay, so let's talk about example 5. It says find the nth term of the sequence. So I have 4, 8 thirds, 16 ninths, and so on and so forth. So I want a sub n is equal to something. Well, a sub n will always be equal to a sub 1 r to the n minus 1. Well, a sub 1 is clearly going to be 4, so I'm going to go ahead and plug that in. Okay. R. I need to find out what R is. N, it wants me to find the nth term. If it's looking for the generic sequence term, the nth term, then I don't need to plug in anything for n. I just need to find out what R is. So from here to here, what did I do? Now, you might have difficulty with this stuff at first. Please be careful with it. Take your time, okay? Notice on the bottom of this 4, there's technically a 1. If I see fractions, what I'm going to do is I'm going to turn everything into a fraction. I'm going to start comparing what's happening, especially if I know it's geometric, okay? Because from 1 to 3, I'm multiplying by 3 on the bottom. Am I doing the same thing on the bottom over here? Yes. What am I doing on top? Well, 4 times 2 will give me the 8. 8 times 2 is going to give me the 16. So it really looks like my R value overall is a 2 on top and a 3 on bottom. So 2/3, okay? So that gives me that I have a sub n is equal to 4, my R value 2/3, n minus 1. That is my generic sequence formula, the a sub n term. So let's go ahead and continue working. We'll look at 5b now. Now I'm going to do that up here on this piece of paper if I can continue doing it here. So 5b. For 5b, you have 5, -10, 20. Now the first thing you know that if they tell you if it's geometric, okay, if they tell you it's geometric, and you see a negative in one or more terms, then chances are one of two things is happening. It started out negative and you're multiplying it by a positive number, or if it alternates, then you're multiplying by a negative number. Notice from 5 to 10, I multiplied by 2, and it's negative. Notice from -10 to 20, I multiplied by 2, and it's positive now. That means that my R value is going to be negative. Again, if it alternates terms, it's going to be negative. So, with this, I'm going to go ahead and use that formula. A sub n is equal to a sub 1 r to the n minus 1. My first term being 5. My R value being -2. And there's my nth term. Okay, again, by plugging it right into those little formulas. Let's go ahead and continue working. We're going to look at 6, the definition. The nth partial sum, again, we're talking about partial sums. You have s sub n is equal to a sub 1, 1 minus r to the n, divided by 1 minus r. Now, this is not a pretty formula at all, okay, such that r cannot equal to 1. Why can't r equal to 1? Because if it's equal to 1, we don't really have a geometric series. If I multiply this by 1, it'd just be 5, 5, 5, 5, 5, 5, 5, 5. It doesn't make any sense for that to be a geometric sequence or series, okay? So this formula is just what we're going to have. If I can find r, if I know what n is, or they ask me what n is, and if I find a sub 1, I can go ahead and find the nth partial sum. Again, why is it partial? Because generally, we'd have an infinite number of these terms. Add it all up. And I'm not adding up infinite terms. I'm adding only up n of them, okay? So, for 7, what if r is equal to 1? Again, if r is equal to 1, then I'm just, it's not geometric, okay? If r is equal to 1, then I'm not adding or multiplying by anything that's changing anything. My sequence, a sub n, would look something like this. Say 5, 5, 5, 5, 5, because I'm just multiplying by 1 every single time. It's not changing anything. It seems silly for us to do this, okay? Not to mention, if I plug in 1 for this, okay, a sub 1, 1 minus r to the n, divided by 1 minus 1. I'm dividing by 0 then, so it's not actually possible for me to be able to do this in terms of this particular sequence. If that's the case, honestly, you're just taking 5 and you're adding it up an n number of times forever, whatever n is going to be. There's no need to use a formula for that, okay? We will go ahead and look at the partial sums in the next lesson.